In less than a decade, Nvidia has transformed itself from a company specializing in producing graphics chips for video games into the most influential enterprise in the artificial intelligence industry. Most advanced AI models in the world, from OpenAI's ChatGPT, Google's Gemini, Anthropic's Claude to many enterprise AI systems, are trained or operated on Nvidia's GPU platforms. Not only selling hardware, Nvidia has also built a software ecosystem, development tools and a widespread partner network, creating a competitive advantage that very few companies can catch up with. For China, this dominance presents a paradox. On one hand, the country's AI enterprises need Nvidia GPUs to develop large language models and AI applications. On the other hand, increasingly strict US export controls make accessing the most powerful GPU lines more difficult. As AI becomes a field of strategic significance, relying on a foreign supplier, especially a supplier directly influenced by US policies, becomes a long-term risk for China. Because of this, the question is no longer whether China wants to reduce its reliance on Nvidia or not, but rather how they will do it. This is not a problem of simply manufacturing a chip as powerful as Nvidia's H100 or B200. The challenge lies in the entire value chain, from chip design, semiconductor manufacturing, high-speed memory, software, programming ecosystems to the capability of commercialization on a large scale. Success or failure will depend on whether China can build a complete AI ecosystem, or just stop at replacing individual puzzle pieces. To understand the road ahead for China, it is first necessary to look at the reason why Nvidia holds an almost irreplaceable position in the AI industry today. Nvidia's greatest strength does not just lie in GPUs. If only considering hardware alone, many companies around the world have the capability to design AI processors with significant performance. What makes the difference is that Nvidia has built a complete platform over the course of nearly 20 years. The CUDA ecosystem is the clearest example. CUDA is a programming platform that allows researchers and engineers to exploit the power of GPUs effectively. Millions of lines of source code, machine learning libraries, AI frameworks and optimization tools are all developed based on CUDA. When a company decides to use Nvidia GPUs, they do not merely buy a hardware device but also access an ecosystem that has been verified through countless real-world projects. This creates a vendor lock-in effect. Even when a GPU with equivalent performance appears, businesses still have to consider the massive switching costs. Rewriting software, testing systems, training engineering teams and optimizing models can take many months or years. In many cases, this cost is even higher than the price difference between the chip types. Besides CUDA, Nvidia also possesses a series of optimization libraries such as CUDA, TensorRT, NCCL and many other specialized tools. These components help accelerate the training and inference processes of AI models, while simultaneously reducing product deployment time significantly. Alongside software, Nvidia also leads in the capability to connect thousands of GPUs into a computational supercluster. Systems like DGX or GB200NVL72 are not simply collections of multiple GPUs, but are platforms optimized from hardware, software to high-speed connection networks. This is a crucial factor when training models with hundreds of billions or trillions of parameters. It can be said that Nvidia does not just sell chips. They sell an entire system that solves AI problems from end to end. This is the reason that makes replacing Nvidia much harder compared to replacing a traditional CPU or GPU manufacturer. For China, the difficulties started to become apparent from 2022 when the US continuously expanded export control measures on AI chips. Initially, Nvidia was still able to sell performance-reduced versions like A800 and H800 to comply with regulations. However, subsequent regulations continued to be tightened, causing even these versions to face export restrictions. The objective of these measures is to prevent China from accessing the most powerful GPUs intended for training large-scale AI models. That does not mean China is completely out of AI chips, but the pace of expanding computational capacity is significantly affected. Many large Chinese technology companies stockpiled massive amounts of Nvidia GPUs before the bans took effect. Alibaba, Tencent, ByteDance and Baidu are all believed to have purchased substantial quantities of H100 or A100 GPUs through previous orders or legal channels that remained open. However, this stockpile cannot meet the demand for many years if AI continues to develop at the current pace. This urges China to accelerate investment in the domestic semiconductor industry with the goal of step-by-step replacing Nvidia's products. Among Chinese companies, Huawei emerges as the most notable candidate. After many years of facing US sanctions, Huawei has strongly shifted its direction toward developing AI infrastructure. The Ascend chip line is considered the company's greatest effort to build an independent AI computing platform. Ascend not only includes processor chips but also comes with the CUDA software platform, Atlas server systems and data center solutions. This strategy is quite similar to the way Nvidia built the DGX ecosystem combined with CUDA. Reports from multiple research organizations show that the Ascend 910B and its subsequent versions achieve significant performance in many AI tasks. Although there remains a gap with Nvidia's most powerful GPUs, especially in training extremely large models, Ascend is fully capable of serving many enterprise AI applications and some large language models. More importantly, Huawei does not set the goal of having to surpass Nvidia immediately. The company aims to build an ecosystem that Chinese businesses can use stably under conditions where Nvidia's supply is no longer guaranteed. Huawei's advantage lies in its integration capability. The company simultaneously designs chips, develops software, builds network equipment, servers and cloud computing solutions. This helps Huawei optimize the entire system instead of merely optimizing individual components. However, Huawei also faces a critical limitation, which is advanced chip manufacturing capacity. Currently, the majority of the world's most powerful AI chips are produced by Taiwan's TSMC on 5 nanometer, for nanometer or more advanced nodes. Meanwhile, SMIC, China's largest semiconductor manufacturer, still encounters many difficulties in mass producing at equivalent nodes due to restricted access to EUV lithography machines from ASML. SMIC has proven its ability to produce some chips at around the 7 nanometer level through various optimization methods, but this approach incurs higher costs, lower yield rates, and is difficult to scale up for mass production. This means that even if Huawei successfully designs a competitive architecture, producing millions of chips with high performance remains a massive challenge. Besides Huawei, China also has many other enterprises participating in the race to develop AI chips. Cambricon is one of the pioneering companies in the field of AI processors. The company focuses on accelerators serving data centers and edge computing. Meanwhile, Biren Technology once drew attention with AI GPUs featuring quite impressive specifications before feeling the impact of export control measures. More Threads chose a different direction by developing versatile GPUs, serving both graphics and AI. Although the company's products still have a significant gap compared to Nvidia, this is part of a strategy to build domestic capacity across various segments. Hygon, Enflame and a number of other enterprises are also developing specialized AI accelerators. Instead of merely focusing on defeating Nvidia on all fronts, these companies target niche markets such as cloud computing, finance, government, or smart manufacturing. The emergence of multiple enterprises simultaneously creates an important advantage. Instead of placing all expectations on a single company, China is building an internally competitive ecosystem, where multiple solutions are developed in parallel. This increases the likelihood of long-term technological breakthroughs emerging. However, hardware is only half of the puzzle. Even if China successfully manufactures sufficiently powerful GPUs, they still have to resolve a much bigger barrier: the software ecosystem. Exactly at this point, the path to escaping Nvidia becomes much more complex compared to simply increasing a chip's performance. If hardware is the foundation of the AI industry, then software is the deciding factor in whether a platform is widely adopted or not. This is also the reason many experts argue that Nvidia's greatest advantage does not lie in transistor counts or processing speeds, but in the software ecosystem that has been built and perfected over nearly 2 decades. For China, wanting to reduce reliance on Nvidia equates to having to create a sufficiently attractive development environment for enterprises and researchers to willingly transition. CUDA is the most obvious barrier. Most popular AI frameworks such as PyTorch, TensorFlow, JX, or thousands of other machine learning libraries are first and foremost optimized for CUDA. That does not mean they only run on Nvidia GPUs, but in reality, the performance and stability on this platform are usually better. A research group looking to train a large-scale AI model always prioritizes a proven environment instead of accepting risks with a new platform. Huawei realized this quite early on when developing CAN compute architecture for neural networks. The goal of CAN is to provide libraries, compilers, and optimization tools similar to CUDA, helping programmers deploy AI models on Ascend chips without having to rewrite the entire source code. Additionally, Huawei also developed Mindspore, an open-source AI framework aimed at building a developer community around its ecosystem. However, building an ecosystem cannot be accomplished merely by releasing software. The value of CUDA comes from millions of programmers who are accustomed to using it, thousands of companies operating products on this platform, and countless documents, courses, and support forums. This is an advantage accumulated over time. To narrow the gap, China must invest continuously over many years, while simultaneously creating enough incentives for businesses to switch to new platforms. A positive signal is that the global AI community is trending towards using more open-source software than before. Modern frameworks are increasingly being designed to support various types of hardware, instead of just optimizing for a single manufacturer. This helps partly reduce CUDA's monopoly advantage, although it is not yet enough to erase the gap. In parallel with developing chips, China also pursues another direction, reducing the demand for powerful GPUs by optimizing AI models. The emergence of DeepSeek is a prime example. In late 2024 and early 2025, DeepSeek drew worldwide attention when announcing language models with competitive capabilities, but trained at much lower costs compared to prior leading AI projects. Although there is still much debate regarding the total cost, infrastructure scale, and actual amount of GPUs that DeepSeek uses, the company's success sent an important message. Algorithmic efficiency can help significantly reduce the need for computing power. This trend holds special significance for China. If unable to access large quantities of advanced GPUs like American companies, the most reasonable approach is to utilize resources more efficiently. That includes various techniques such as low-precision mixed training, model quantization, parameter sharding, mixture of experts, MO, training schedule optimization, and inference algorithm improvements. These improvements do not completely eliminate the need for powerful GPUs, but they can significantly reduce the number of chips required to achieve the same result. In a context of restricted supply, this is no small advantage. From another perspective, China is also changing how it builds AI clusters. Instead of relying on a small number of ultra-powerful GPUs, many enterprises choose to connect a massive number of medium-performance chips to form large-scale computing systems. This strategy has the advantage of leveraging domestic manufacturing capacity. If a domestic GPU only achieves about 60 to 70% of the performance of an Nvidia product, using more GPUs can partially compensate for the gap. However, this approach is only effective when the high-speed networking infrastructure is good enough to reduce latency between chips. If the connection is not fast enough, the performance of the entire system will drop sharply. This is why connection technologies like Nvidia's NVLink are highly rated. Not only having powerful GPUs, Nvidia also invests in high-speed data transmission networks through the acquisition of Mellanox since 2020. Thanks to that, Nvidia's AI clusters can operate as a unified system instead of multiple individual GPUs. China is developing its own connectivity solutions to narrow this gap, but still needs more time to reach an equivalent level of perfection. Another issue that is rarely mentioned but has a huge impact is HBM, high bandwidth memory. In modern AI, data access speed is often just as important as processing speed. A GPU with very strong computing capabilities, but lacking memory bandwidth will not fully leverage its performance. Currently, the HBM market is almost entirely held by three leading enterprises, which are SK Hynix, Samsung, and Micron. Specifically, SK Hynix is the primary supplier for many of Nvidia's high-end AI GPU lines. Accessing advanced HBM sources therefore becomes a challenge for Chinese chip manufacturers. In recent years, China has invested heavily in the semiconductor memory industry with enterprises like CXMT or YMTC. Despite achieving much progress in certain segments, the gap in advanced HBM remains quite large. This shows that the problem of replacing Nvidia is not only related to GPUs, but also drags along the entire component supply chain. Another notable point is how China utilizes the scale of its domestic market. This is an advantage that very few countries possess. China possesses a number of internet enterprises, data centers, and AI users that are among the largest in the world. Alibaba Cloud, Tencent Cloud, Baidu AI Cloud, ByteDance, and a series of other technology companies all have immense computational demands. If these businesses simultaneously transition to using domestic chips, local manufacturers will have a market large enough to continue investing in research and product improvement. In the semiconductor industry, production scale is an extremely important factor. As the number of chips sold increases, the cost per unit will decrease, while the business simultaneously gains more resources to invest in the next product generation. This is the cycle that Nvidia has leveraged very successfully over the past many years. China is trying to create a similar cycle by means of its own domestic market. However, this strategy also has limits. A large market can help an enterprise survive, but it does not automatically generate advanced technology. If the technical gap is too massive, market scale only helps sustain operations and is not necessarily enough to catch up with competitors. Another advantage of China is the coordination capability between the state and enterprises. In many strategic sectors such as high-speed rail, renewable energy, or electric vehicles, China has previously proven that long-term investment on a large scale can forge globally competitive businesses. The AI and semiconductor industries are also benefiting from this approach. Many national investment funds are established to support semiconductor enterprises. Universities expand microchip training programs, while localities compete to attract research centers and chip manufacturing plants. These policies do not guarantee success, but they help the industry have stable resources for a long time. Even so, it also needs to be acknowledged in a balanced way that large-scale investment is not synonymous with high efficiency. In the past, China had quite a few failed semiconductor projects due to poor management or unfocused investments. Some enterprises received large amounts of capital, but did not create competitive products. That shows investment capital is a necessary condition, but research capability and commercialization capacity are indeed the deciding factors. Up to the present moment, it can be seen that China no longer pursues the simple goal of copying Nvidia. Instead, the strategy is gradually shifting toward building an AI ecosystem that can operate independently within the domestic market. This is a significant difference. Instead of competing head-on in every field, Chinese businesses focus on ensuring that domestic companies can still develop AI even when they cannot access Nvidia's most advanced GPUs. It is this change in objectives that could be the deciding factor for the likelihood of success in the coming years. If the goal is to surpass Nvidia in every aspect in a short time, the current prospects remain quite limited. But if the goal is to build an ecosystem strong enough to gradually reduce dependence and meet the demands of the domestic market, that path is becoming much more realistic. Nevertheless, evaluating China's prospects would be unbalanced if only looking at the progress achieved while ignoring the remaining barriers. The path to reducing reliance on Nvidia is still a multi-layered problem, in which each layer requires time, resources, and coordination capabilities across multiple industries. The first challenge is the gap in advanced semiconductor manufacturing technology. In the chip industry, design is only half the story. An excellent design will not yield an advantage if it cannot be manufactured in large volumes, with high yield rates and reasonable costs. This is precisely the advantage that TSMC has built over many years, and is also the reason Nvidia can continuously roll out new GPU generations with outstanding performance. For China, SMIC has achieved many notable steps forward under the conditions of restricted access to modern production equipment. However, the lack of ASML's EUV lithography machines makes the manufacturing process for advanced nodes more complex, with higher costs and difficulty in scaling up. That does not mean China cannot produce AI chips, but it will affect economic efficiency as well as the pace of product upgrades. Another barrier lies within the global supply chain. A modern AI GPU not only includes the main processor, but also needs a series of auxiliary components and technologies like HBM memory, advanced packaging materials, testing equipment, chip design software, EDA, and manufacturing automation tools. In many segments, enterprises from the US, Japan, the Netherlands, and South Korea are still holding leading positions. This means that even if China achieves progress in one stage, they still have to resolve bottlenecks in other stages. In other words, replacing Nvidia is essentially the process of rebuilding a complete industrial ecosystem rather than just developing a single product. A notable factor is that Nvidia's pace of innovation is not slowing down either. While competitors are trying to catch up with the H100, Nvidia has moved on to the Blackwell architecture with the B200 and GB200 lines. The company also continues to introduce new platforms like Vera Rubin in its development roadmap for the coming years. The gap, therefore, is not a stationary target. It changes continuously as the leader still keeps investing very heavily in research and development. Besides that, Nvidia also benefits from a widespread partner network. Microsoft, Amazon Web Services, Google Cloud, Oracle, Meta, OpenAI, xAI, along with many other businesses all invest in infrastructure based on Nvidia GPUs. This massive deployment scale generates an amount of real-world operational data that rivals find very difficult to obtain. Each new generation of Nvidia products is improved upon based on deployment experience across thousands of data centers worldwide. Conversely, China also possesses its own advantages that should not be taken lightly. First is the scale of technical human resources. Every year, China trains a large number of engineers in the fields of electronics, computer science, and artificial intelligence. This is a vital resource to maintain the pace of research in the long term. Second is the extremely broad AI application market. AI is being deployed in e-commerce, finance, manufacturing, logistics, healthcare, education, and many other sectors. This practical demand creates conditions for businesses to continually test and perfect their products. Third is the integration capability between hardware and applications. Not every business needs the world's most powerful GPUs. With many tasks regarding AI inference, image recognition, language processing, or factory automation, a system with lower performance but cheaper costs and stable supply might be a more reasonable choice. This is exactly the point where Chinese chip manufacturers can compete. Instead of trying to claim the leading position in every segment, they can focus on markets where performance requirements are not overly extreme, but the scale is enormous. Another trend that could also alter the competition is the development of specialized AI. The 2023 to 2025 period primarily revolved around massive language models, requiring a very large amount of GPUs to train. However, many enterprises are transitioning to smaller models, which are optimized for specific individual tasks. These models consume fewer resources and can run on various different types of hardware. If that trend continues to expand, the advantage of the most powerful GPUs could relatively decrease in certain segments. This opens up opportunities for new chip manufacturers, including Chinese enterprises. Even so, it is also necessary to avoid an extreme assessment that China will entirely escape Nvidia soon. In the medium term, this is unlikely to happen. With the most advanced AI models, especially very large-scale training projects, Nvidia's GPUs still maintain clear advantages in performance, stability, and software ecosystem. A more realistic scenario is market divergence. In the world's leading research centers, where the largest models are pursued and maximum performance is required, Nvidia is highly likely to still maintain the leading role in the coming years. Meanwhile, in China, the proportion of domestic chip usage could continue to rise thanks to supportive policies, the need to ensure technological security, and the gradual maturation of ecosystems like Ascend. This does not mean Nvidia will disappear from the Chinese market, but rather that its previously near monopolistic position will gradually shrink in certain segments. Looking further ahead, this competition also reflects a larger trend in the global technology industry. For many years, The semiconductor supply chain was built towards globalization, with each country handling the stages where it held an advantage. However, geopolitical tensions have prompted many economies to start pursuing autonomy in strategic technologies. The US promotes domestic chip production through the Chips and Science Act. The European Union rolls out the European Chips Act. Japan and South Korea are also stepping up investments in the semiconductor industry. China falls within that general trend, but faces greater pressure because of export control measures. This shows that the competition is not simply between Nvidia and Chinese companies. It is a race between two technology development models. One side relies on a global ecosystem with leading enterprises at every link. The remaining side leans toward building a supply chain capable of operating independently even when restricted from accessing foreign technology. As of the present moment, there is not enough basis to affirm which model will achieve absolute dominance. Nvidia still possesses massive advantages in technology, software, and ecosystems. Meanwhile, China has advantages in market scale, long-term investment capabilities, and the determination to develop domestic technology. The final result will depend on the pace of innovation from both sides, rather than just China's capacity to catch up. Looking at the big picture, it is evident that China's goal of escaping Nvidia is not about replacing one brand with another brand. It is the process of building autonomous capacity across the entire AI value chain, from chip design, semiconductor manufacturing, memory, software, data center infrastructure, all the way to the programmer community. This is an ambitious goal, and will not be able to be completed in a few years. However, developments in recent years show that China has transitioned from a state of dependence to proactively investing to create alternatives. The gap with Nvidia remains significant, especially in high-end AI GPUs and the software ecosystem. But that gap is no longer stationary. Nvidia continues to advance, while China is also accelerating with massive resources and a long-term strategy. Therefore, the question, can China escape from Nvidia, should perhaps be replaced with another question. To what extent can China reduce its degree of dependence on Nvidia? With what is currently unfolding, the possibility of reducing dependence in many domestic AI applications is becoming increasingly realistic. On the contrary, totally replacing Nvidia in the most advanced AI segment will remain a massive challenge for many years to come. The competition therefore will likely not end with one side eliminating the other, but rather with the formation of two major AI ecosystems coexisting, competing and developing in parallel amidst a context where technology and geopolitics are increasingly deeply intertwined.